Okay, welcome everybody who's here for my talk. You have two other better, maybe alternatives, but you chose to come here, so thank you very much. Okay, so I'm here to talk about how you can boost your LLMs with event streaming and retrieval augmented generation. But first of all, may I ask you, how many of you are already working on Gen AI types of apps? Maybe a few. Okay, yeah, quite a few. So, and actually, also let me ask too, how many of you are working with, let's say, vector database too, like maybe? Yeah, just a few. Okay, that's cool. I just am curious because I've been also like traveling as a developer advocate myself. I just travel to different places. I just want to get a feel like of each region of the world. There are different like, you know, kind of adoption of Gen AI. And it's very interesting because as we know, Gen AI, ChatGPT is now taking the world by storm. And there are just a lot of talks, a lot of things. There are many things, you know, around this, so it will be interesting too. Okay, so I'm gonna start. So this is the agenda. So I'll just first talk about who I am first very briefly, and then also because it's a 30 minutes thing, so I have to be quite fast and brief too, so pardon me if I may be skipping over something or not explaining something, but I will give you my contact information and also my company information, all the products that you can also, you know, always come to us too. So this will be sort of an introduction, and hopefully it will you know, pique your interest if you are curious about it. And then if you are here, already heard about it, pardon me if it's kind of a little too slow for you, but I have to assume too, kind of lowest common denominator, maybe not everybody is familiar with it. So, okay, so just a brief introduction to that I'll be bringing forth. And then also discuss then why we want to get into, you know, boosting LLMs. What are some of the drawbacks? And also the options for improvement, and then also with RAG, how RAG can help. And also wanting to introduce to you an open source library that my company is working on called Langstream. So, and also a quick demo. I hope I have enough time to also show you something fun too. So that's the plan. Who am I, first of all? I'm Mary Grygleski, and I'm a senior developer advocate at DataStax. DataStax is a company here based here in the Bay Area in Santa Clara. How many of you actually have heard of DataStax or familiar? Okay, so quite a few. How many of you are using Cassandra by any chance? Okay, yeah, so great. And also, let me do a bit of promo here. Cassandra Summit in December. So I also have promo code, so I do want to you know, encourage all of you to go, not just about Cassandra, but there's also AI Dev co-located too. So, so that's kind of exciting. We're kind of getting up, you know, ready for that too. So, okay, so DataStax. So I actually joined DataStax real quickly last year as an event streaming advocate because we have adopted Apache Pulsar. So we are very much an open source company, Cassandra, and then also Pulsar. And we also have a managed cloud platform called Astra. So that's something I want to share with you as well later. And then, okay, so that's about my company. I'm a developer advocate there. As you know, as developer advocate, we travel everywhere and then bring goodness to all developers. We want you to succeed. We want to share with you all the knowledge as well. Anyway, so here's my background. I'm a Java champion. I've been actually working with Java the most, you know, among other languages. I'm also the president of the Chicago Java Users Group. And these are just some of the things I've been working with the Pulsar. Also, I was at IBM previously as an advocate for 3.5 years. So some of the open liberty, open source stuff. So I've been like with open source for quite some time. And then about maybe 4 months ago, my company decided everybody's going to work on Gen AI, and we have our vector database. Actually, it's Cassandra. We added in vector data type, and also some other goodies too, which I'll share with you in a little bit as well. So we like to encourage you too, if you are looking into Gen AI solutions, look into our company, what we can offer for you too. And these are just my contact information. Again, I'll share with you towards the end of this presentation. Okay, so I'm going to just start first. Brief introduction to Gen AI and ChatGPT. As we know, ChatGPT came out, right? The version 3.5 that shocked the world was like a year ago, November of 2022. So since then too, everybody's been like excited and a lot of confusion as well. So here too, let's kind of take a look at what it is. In my case too, because my company said, let's work on it. So I started looking into it. And as such, too, when I started working with AI, prior to that, too, I didn't have as much of an AI, even though I did some work with it, actually with streaming, with reactive streams, with another speakers, too, on machine learning reinforcement. So I just thought this is a great way for me to get back to doing some really formally into AI. So, and I found out Gen AI is certainly different, and it's bringing a lot of excitement. But first of all, too, let's take a look, brief introduction to Gen AI. Essentially, too, if you kind of think deep, it's really about automation. We don't want to do the work, human beings, and we want actually machines to do it for us, and that's the ultimate goal. And this actually also, again, for those of you maybe if you're somewhat new to this field, and it involves a lot of data, because only with data that we can actually kind of bring out what we're trying to look for, right? Data is of utmost importance in the AI field. And as such, too, this is like the famous diagram, like describing, like an onion, describing AI. AI essentially it mimic intelligence or behavior pattern of human beings and, or any other living entity, right? And then machine learning is kind of, if you kind of get deeper into it, it basically deals with techniques in which the computer can learn by, from data, and not so much about us kind of writing code, so to speak, but it's really you want to train the computer to think in that case. And then actually further deeper down is basically you want really to inject intelligence into it, and that's when deep learning is, kind of in the core of it, the neural networking that really mimics how our brains, the neurons kind of work too. So that's a real quick intro. So fascinating look, into the Gen AI era. So what is Gen AI, right? So it's a disruptive field in AI. It has the potential to change the way we create content and consume content. And basically, it generates contents, and it's very important, will be based on prompts, right? Prompts is what you actually guide, what you want to try to search for, and then, have the bot have this AI, the artificial intelligence bot to kind of search for answers for you. And it generates contents. So it uses combination of machine learning and deep learning to produce the contents. The thing is, though, with Gen AI, and actually before Gen AI was actually more predictive AI, so it's not really that new in some sense. However, predictive AI is really dealing more with analyzing data. And also the purpose of such is perhaps making more business forecast, weather forecast. So as you can see, it's a bit more kind of business-like, so to speak, but it also has a time kind of like valid or expiration to it. Because if you're making business forecasts, you usually say a 5 years forecast, and you kind of, based on some data, you generate some kind of, predictions on it. But the thing is, though, 5 years after, or even just 1 year in today's world, it will be expiring. It doesn't become valid anymore. However, or even like another example would be weather forecasts too. You can use predictive AI. But the thing is, the Gen AI is kind of disruptive is because now, as we all know, you basically are working with kind of things on more of the creative side. You can have it write an essay, generate images, and actually the more kind of more desirable thing would be like the multimodality in which you can actually have text and telling it some stuff and have it find the images that you need or generate, whatever it is. So, and then as such too, it can also be dangerous too, as we know, because you can actually kind of tell it to do something and it goes and does maybe put your image on and kind of pair it with some big, kind of criminal kind of person, and then you could be incriminated because of that. So stuff like that. So, well, I don't need to describe too much now. So let's take a look then into GPT, right? Generative pre-trained transformer. So essentially, that's what it is, kind of mechanism to kind of make it happen. So essentially, GPT will take simple prompts, right, in human language, and that's what also the difference is that now we can actually give inputs like we talk to one another. No longer is it restricted to how we used to be, or still we are programming. There are certain rules you need to follow. If you don't follow that, it won't give you the results, right? So that's the thing too. A GPT is that you can take human conversational languages as input and then have it do pattern matching or similarity searches and then return you the results, the responses too. So that's what is fascinating is that now it can produce contents like writing an essays, writing a piece of music, and generating code for us. And most of us here, I believe you're a developer, so that's pretty fascinating. So to me, I find that Gen AI definitely has its value. It's not going to take away our jobs, but it's probably going to take away a lot of the mundane things. If we can kind of train it to do all these mundane things that, then we can free up to be doing things that are more creative, is what I'm looking at. Okay, so this is just a really quick kind of history too. So it only started up, GPT, in like 2018 too. That's when Alec Redford's paper on GPT came out of a language model. It's published on OpenAI website. So the reason I'm bringing this up is that this really came on fast. It's like you go, going in the ocean and the waves coming, and it's basically, oh, you see it coming and it's here, within 5 years, and the waves keep coming too. So as you can see, then GPT came out 2018, then 2019 was the GPT-2, and then fast forward to a bit, in 2022 when Stability AI developed Stable Diffusion. So that also kind of immediately changed the whole kind of trajectory too, because it now allows you to do text to image type of model from there. And from there, that's when DALL-E came out and Midjourney, for example. And then very soon too, everything kind of happened, like really, like the waves come, stronger and stronger. And in 2022, just a year ago, November 30th, that's when GPT 3.5 got released. And within 5 days, it reached 1 million users. So it's very disruptive too. So, okay, so without going all the details, we know that this whole waves is continued to kind of come, and also too, there are things that we have yet to discover. I think that's what the exciting thing is, and that's what we are all on the journey, to kind of work towards it, and really like we're discovering new things as we go. Okay, so now a bit of a kind of more the kind of basic terminology, NLP. So NLP is a interdisciplinary subfield of linguistics of computer science. As such, it relies a lot, on the input is dealing with languages. So we need some kind of, way, kind of studies or kind of a model kind of discipline to kind of guide us. So that's when NLP came out, and then it also basically helps to process natural language data sets, right? Those huge data sets, all of these things, and it uses like rule-based, probabilistic machine learning type of approaches too. So it enables computer to learn from contents to including the contextual nuances of the language itself. And so the thing is that with generative AI is that you're not just like asking it to do something, but we're expecting it to be more intelligent and draw insights from all of the documents that it can find too. So now then it leads to like LLMs, large language models, and that's what I think a lot of developers we're working on these days are the LLMs. That's what we interact with. It is a type of machine learning model, the foundational model. But the thing is that is, in general too, we don't kind of do kind of pre-training on it because it's just very expensive and it's huge amounts of data, and it takes days, even, kind of like taking many GPUs is going to take days or weeks, even months, maybe sometimes to train it. So that's why there are like large corporations that are kind of forming consortiums, OpenAI, for example, that will generate these or pre-train all of these large language models. So the idea is that LLMs is what we kind of interact with. There are APIs that kind of allows you to interact with it as well. It answers questions like from the prompts, like a human being. It analyzes the sentiments and kind of really good for chatbot type of conversations. That would be one example. And then some examples of the API and frameworks that we use today for this will be LangChain, Llama 2, and also Palm, which is from Google, and then Hugging Face as well, among many other libraries too. But these are kind of like the major ones. And then me being more of a Java person, if you're a Java person, then there's also, for example, JLlama is actually one of our chief architects at DataStax. He developed JLlama, is a Java port of the Llama library. And then also there's a JVector too, is our founder of DataStax. He designed that, and it works with Project Panama, if you're familiar again with Java. And essentially it supports like SIMD type of operations too. So it enables like vector search to be super fast, and also deals with the storage too. So I won't get into all the details, but these are the links. And then there's also LangChain, also has a port to, basically it's in Java, it's called LangChain 4J, and also Llama 2, which is a port of Llama C. So these are just examples if you want to start experimenting with it. Okay, so now let me then also, before getting into RAG2, let's also understand what vector database is. And that's also one of the, kind of primary things that my company is working on. And it's basically, vector database is a purpose-built database, right, that serves up vector data type, So the purpose of it is to handle complex machine learning type of searches and all of these things. And you may also have heard of, too, it works with vector embedding. So essentially, if I kind of describe to you, vector embeddings is essentially, it takes maybe like a prompt, a strings that comes in, and it tokenizes, it breaks it all up, and basically translate this, your tokens, each string, it translates it to a numerical representation of it. So in other words, if you kind of look into a vector database, a table, if you do a select on a vector data type, it will come back with an array of floating point numbers for you. So they kind of represent all of these strings that you want to kind of insert into your database. So the purpose of such is that it's being stored very efficiently in that format, as well as for searches and queries too. And it's basically an automatic feature engineering type of kind of database. And also, if you kind of ask me what type of mechanism it uses, right? The algorithm it uses, for example, in Cassandra, the vector database, or we call it Astra, DB vector, is basically uses this approximate nearest neighbor, like ANN type of mechanism to do the proximity searches too. So. Okay, so now I brought up again, going back to vector embeddings, what is it being used for, right? So essentially, it's used for searches, right? So the results too are ranked by relevance to some query string too. That's what it's for primarily. Then you can also use it for clustering, as well as like recommendations. I'm sure if you've done shopping and you do all of the recommendations, you can use that vector embeddings type of data to do recommendations too. And also anomaly detection, diversity measurement, and classification as well. So these are just some of the examples of how you can make use of vector embeddings. Okay, so then let's kind of go back a little bit. There's vector database, and I got asked the questions, why can't we use traditional database? So database such as Postgres, a lot of folks are using, and I understand Postgres also has vector database capability. I think it's called PG Vector, all of these things. But the thing is, though, let's take a look at traditional database. The thing is, you can still use traditional relational database. However, we're talking about lots of data, and how do you deal with it, right? So it would take a much longer time. The performance will suffer too if you kind of use traditional relational database. The reason is that in machine learning, Gen AI type of scenario, the data will be best kind of being stored and also being searched upon and everything. Because the thing is that we're dealing with data that we want to identify patterns and the dimensions and the relationships. So basically, too, using vector data type is the fast way. Like if you are kind of math major, you understand it is linear algebra behind the scenes, using Euclidean searches and also cosine similarity kind of searches behind the scenes. So actually, I have to kind of say, too, it's funny. I was actually a math and computer science major many years ago. And I remember back then in college, I was like, oh, what do we use it for? I never could understand vector math, right, and matrix and all of these things. But now I do. I finally have a job that actually is making use of my linear algebra kind of skills in it, even though not every day, but it actually helps me a lot to immediately understand how linear algebra is being applied. So this is an area. Okay, so that's that. And then now, let's kind of real quickly then talk about drawbacks of LLMs. And this is the title of the talk is Boost Your LLMs, right, with RAG. So let's take a look to LLMs, what are the kind of some drawbacks of it. Kind of if you look into, the barrier of AI. As we know, in traditional machine learning, if you look at it, well, machine learning is always you get the training largely, broadly kind of divided up. The steps are training phase and also inference phase. So as you can see, there's training data coming in. There's machine learning engineering. You produce the model. The model is then used, to kind of use for inference. It's basically that's when you kind of use it and apply, apply techniques to kind of search based on the model for what you're looking for, like that. So that's kind of traditional ML. The thing is, though, if you kind of look into this too, the training phase will cost a lot of money too, as we kind of already understand, right? Usually we're dealing with data. It's come in large corpora of data. Comes in, you need to gather the data, clean it, store it, process all of these things. And it's also hard to find people, enough people, data scientists, to kind of understand and work on it too. The process itself is also very long, and it's basically, not reusable. It's not just very efficient, that's the thing. So now comes Gen AI, and that's when we talk about these large LLMs for GPT type of usages. Same thing you get, on the training phase, you're still training all of this. And then now with Gen AI is that then we have the input of the prompts that are coming in, and then inference phase will also involve the chat completion kind of phase, and then generate you the next tokens and words, all of these things. And then if you kind of take a look into it too, basically too, the LLMs itself also has a lot of shortcomings too. So let's take a real quick look into it. So LLMs are basically parametric. It can't memorize all of the knowledge, right, in their parameters too. It kind of has limitations. And they're also probabilistic too, because for example, in an example like here, it's like capital of Texas is, it can return you a whole bunch of things based on all of the measurements of the results too. And then also too, the another shortcomings of LLMs are that it is opaque too, meaning that it's not really possible to interpret, explain, or add some annotations to its answers too. It's pretty much kind of static. And also training LLMs is expensive, as we all know, right? It's also not possible to add or remove knowledge from it. It's kind of really a chunk of things is there, that's all you have. But what about, right, if it's, think of some ideas to improve, you can always create your own foundation model, but the thing is, in reality, it's not possible because it's so expensive, and that's just not possible for anyone to do it, unless you're really a richest guy, maybe even he can't do it. And you can also think of fine-tuning and retaining an LLM on new data. However, with fine-tuning too, it also has its shortcomings too. It's not really recommended, in fact, not the kind of good way. And then, of course, there's also prompt engineering too. It's basically you want to tweak, your input to coax the output. So that's what it is. But let's take a look then into prompting too. So using Gen AI is also about building the prompts too. So the problem to solve, is no longer in the model, but it's in the prompt too. However, if you kind of take a look into prompting too, it's basically also the size of the prompt is limited as well. As you know, right, you are still working against the same corpora of LLM data in there, so it may not be ideal too. Okay, so and then actually let me kind of skip that part because I want to still show a quick example too. But that one is kind of repeating anatomy of a prompt. So to kind of summarize is that the problem is that the domain-specific data is really huge too. So you can be training an LLM, or let's say the LLM is taken from 2022. Then what happened between the time of 2023 and now? You get that whole chunk of data not in the LLM, then how do you kind of handle it, right? So this is when the RAG pattern, the retrieval augmented generation pattern can become useful in here. Let's take a look then to see what is RAG, right? So RAG is basically a hybrid framework that integrates two components of these RAG models. One is the retrieval model, and the other is the generative model. So the purpose is that you want to be able to produce text that's not only contextually accurate, but also information rich. That's the idea. So let's take a quick look at the retrieval model. In a nutshell, right, the retrieval model acts like a specialized kind of librarian. So it pulls in all of the relevant information from a database or a corpus of documents too. And this information is fed into the generative model. So the generative model, think of it as like a writer. It takes all of these data that's been retrieved on the retrieval side, and it crafts it into some coherent and informative text, based on their retrieved data too. So basically, the RAG model involves these two kind of work. They work in tandem to kind of provide answers too that we are hoping to be more accurate and also contextually rich too, using this model. So now, and I just want to kind of quickly kind of squeeze in this, is that the mechanism that's basically used, in doing vector data. In a RAG model, you could also be kind of having data that's kind of, you're taking it and then also inserting into the database, vector database as well. So this kind of quickly explained, but I realize I don't have too much time, so I won't explain too much, but I'll share with you if you want to take a look at these, kind of slides. Because normally I do this talk like 45 minutes, so now I kind of have to kind of skim over, but I want to leave you still with these slides if you want to look at. Okay, so these are dealing with vector search and vector store too in that. But let's kind of take then quickly look into the generative model. Generative models, basically the role is, again, like as creative writer, you synthesize the retrieve information into coherent and contextually relevant context into the text, right? And it's built upon the LLMs too, and it has the capability to create text that is grammatically correct and meaningful and aligned with the initial query or prompt. So in other words, you kind of separate concern. You're dealing with the generative side. So it takes the raw data from the retrieval model and give it more of a narrative structure too. So then it kind of produce, the content to be more digestible in that case. So essentially too, over here is in the rank framework is that the generative models will give you, it's like the final piece of the puzzle and gives you the textual output that you can interact with. Okay, so now then real quick introduction to LangStream. So LangStream is, again, an open source library that my company, DataStax, is working on, one of our teams are working on. So this is just a diagram describing it too. As you can see, LangStream too essentially relies heavily on an event streaming type of model. So if you're familiar, some of you may be working with event streaming, it's basically, it's like, well, I guess if I can say, a platform that maybe a lot of you are familiar with would be Kafka, for example. So you basically can have data stream in real time, asynchronous data kind of stream in. So that's the idea, is that there are also connectors that we work with as well, and we also work with LLMs, all of the OpenAI, Vertex AI, Hugging Face, all of these. And also then it works also with vector stores. So not just with Cassandra or DataStax, our Astra DB, but also Pinecone and Milfus too. These are other choices of vector database. Again, messaging is Kafka. You can have it kind of plug in as a source of data feeding into your model, processing it, and also Pulsar as well. And then also, then it works with LangChain, like the libraries I mentioned earlier that works with, that you can build out templates or different types of things that you need to interact with LLM. Llama index as well, and all of these things, and connectors too to other databases, right? That behind the scenes there's Snowflake or MongoDB, all of these things. So it's a very flexible kind of library in there. So over here too, it's basically works with Kafka. And also, too, wanting to describe to you a little bit in a hurry is that it's composable, too. The model it uses composable agents, too. So in a pod, you can have sources, and sources can be kind of, you build, like have Kafka, Pulsar, all of these sources built in, and you can build different agents that are processors that process all of the data that comes in, too. And then when you're kind of after processing, you output all of your data to a sink like that. So these are just list out all of the different connections it has. So it's very flexible. So also, too, the benefits of using a library like LangStream is that it's declarative style and also low code, too. So you basically can capture all of your coding needs, essentially, in configuration form in YAML file as well. So this is just an example of a low-code YAML file example. And here, too, is an example application, for example, a RAG chatbot too. You can have different pipelines that essentially do different things at the same time that feed into this chatbot interaction too. So I realize I really don't have time. So just want to really quickly kind of describe too with LangChain what the problem it can help you with, right? So a typical pipeline, you try to kind of bring data to a vector database. For example, you want it to be able to read data from a source. So the source can be an S3 bucket, a website, or Kafka topic, or Pulsar topic, and then process the data, and then extract the data to vectorize it. And then you do need to also split the text into chunks of a given size, and then compute these vector embeddings. Again, you need to convert all of your data, and then, and chunk it, everything, and then write these chunks to the vector database, and then clean up obsolete data from the vector database. As you can see, there are lots of steps that are involved in here. So this is like typical pipeline, that brings data, and then this is in YAML file. You can describe everything in a YAML file too, and you don't need as much of a, kind of coding because it's already there. So just a quick kind of diagram describing it, and this is what it is, a RAG AI applications, and then, you have this look in here. So, and I realize really don't have time, so I'll really quick kind of like get to the demo part. Just wanted to kind of show you quickly too. Let's see here. Where did it go? Okay, so if you go to this site, we have langstream.ai, or yeah. Anyway, I have it on my slides too, so I will show it to you. So basically, too, this is a quick start if you want to put your hands into working with this Langstream. Basically, this example too is so quick that it really doesn't take you too much time, and you first have to install the Langstream, and then also make sure you have open AI access key, and whatever key you set up in your account, and then essentially too, you also need to have Docker running, and essentially then bring this up too. And then you can then interact with it. So it's just a real quick one, so let me quickly kind of show it to you. I already have this, although I was having some issue earlier. I think you can see that, okay. So all of the things I've already installed Langstream, I have my Docker up and all of these things. So I just need to run Langstream Docker run tests, and that's what is required of this particular example. And it will run, and then when it's ready, we also have a simple HTML page that you can interact with the chatbot too. So yeah, let me see. Again, I was having some issue with it. I don't know. It's always like that when you're ready to do demo, then something goes wrong. But this is the idea. Like if it runs too. In fact, I did actually a podcast with my colleague. We were doing this podcast on Gen AI, and then I actually showed this, and it was right before, or actually on the day of Halloween. So I was just saying that, please compose me a Halloween poem. It actually did, and it was really fun too. It's basically using a Christmas song and kind of plug in all of the Halloween kind of characters in there. It was kind of fun too. But let's see if it works now. But if not, you can always go to this site, download your Langstream, and try this out yourself too. Okay, so this is still, while this is still running. Okay, so. I hope it's making sense because it's kind of short. Okay, here we go. So it comes up, which is good. And let me kind of increase the. So basically in here too, it makes use of, you're producing messages, it's using Kafka in this particular example. So you can connect to it. And then, there's a status is failed. Not sure what is going on. That's what was happening to me. Let me try it one more time. Oh, this is kind of crazy, but you get the idea. It's basically, you can connect to it. Sometimes it might have issue, not sure what is going on. But the idea is that you can then quickly say stuff like, write a poem or something. I don't know if it works, but I think that actually the producer status is failed, so I'm not expecting this to be working. In fact, okay, well, I'm so sorry about that, and I think I'm time's up too because my host is standing up right there. So yes, okay. Well, anyway, let me kind of go back to it, but you get the idea. You can quickly basically install Langstream and then get your OpenAPI key and then have Docker up, and then you run this command, Langstream Docker, and then you should be able to follow the instruction. You'll be able to bring this up, and maybe I'll do it in our Q&A session. Let me try to fix it and see what's going on. Okay, anyway, let me go back to my slides. Where's my slides? Can't find it. Okay, I think maybe this might be where it is too, sorry. Okay, yeah. Okay, here, it's actually in the same browser. Okay, so, and thanks for your patience with me. So hopefully, like I said on the Q&A session, I'll fix that. So thanks for staying, and I know I'm running out of time, but I want to share with you the resources in here. This slide deck can be accessed here if you are interested. And again, if you miss it, don't worry, because I will be sharing the slide deck with the organizers here too. Okay. Okay. All right, thank you. Yeah, thank you. And then these are some more access, and also our Astra database. I didn't even get a chance to show you. We'd like to encourage you to sign up because we give out $25 per month as a free credit. You can use it for, to build a vector database. I think we allow you to build on your project and just to give it a try. That's a vector database on Astra. And also I have my Twitch stream. This is my Twitch. I'm trying to resume it very soon. And then with that, thank you very much. And this is my LinkedIn and my X Twitter handle, and also a Discord server too, if you like to stay in touch. So thank you very much, and I appreciate you coming to my talk. Thanks. Oh.